Sorry I couldn't be here to do this, but we're going to look at the lab the same way you would have. This is something we would have done in a really small scale in the classroom. So here you're going to see slightly bigger reactions. I'm actually going to make the videos separately so that they can be shared not just with you, my students, but with any student who ended up missing the lab. But the idea of the lab is we mix a chemical and another chemical, both of which are aqueous. So I will sneak some in here. Pretty much all of these are clear and colorless. So that is one of our clues, but we can also use our solubility rules to confirm that this nitrate, rule number 2, and this thing with sodium, rule number 1, are both aqueous. So over here, we would write our chemical formula. It's this chemical reacting with this chemical. We swap partners. Phosphate now goes with silver to make silver phosphate. Sodium now goes with nitrate to make sodium nitrate. And then we knew that our reactants were aqueous because they were clear, colorless liquids. But when we did the lab, we would have seen a change, and we'll see that there in the videos. We have a solid. By using the solubility rules, we can confirm that anything with sodium or nitrate should be aqueous, and most things with phosphate would be our solid. That's how we can get to that. So, what's really important here is recognizing we swap our partners, but then we use the charges on each. On the +1 sodium, the +1 silver, the -1 nitrate, and the -3 phosphate to figure out what we are making. Here, same idea. Lead to nitrate and sodium sulfate swaps partners. So the lead with the sulfate, in this case, we have intentionally bolded the things so the bold two things end up together, but you have to think about the charges. The non bold things end up together. You have to think about the charges in each case. So we have swapped it. We have balanced it as 1, 1, 1, 2 in this case, because we have to have two sodiums and two nitrates to balance out what we see on the left. And then we're the same idea. We very intentionally used sodium in all of these compounds because sodium isn't going to be our precipitate. We can think about what the other chemicals do. So here, iron chloride, or technically iron 3 chloride and sodium carbonate, we swap. We make iron 3 carbonate and sodium chloride, and we've got that. The solubility rules tell us aqueous, 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 but then it tells us with the carbonate, with the phosphate, and with the sulfate that we do have some insoluble cases. Just like in the notes, we can turn each of those reactions into an ionic drawing. Our silver nitrate up here is aqueous, and there's three of them, so I showed three silver and three nitrate ions. My sodium phosphate was aqueous, so I show sodium ions and phosphate ions in the correct 3-to-1 ratio. My products was three of these and one of those. So I have three sodium nitrate, sodium nitrate, sodium nitrate. I am showing them separate because they're aqueous. That's what aqueous means, dissolved, separated, and dissociated. And I am showing them with their charges because the reason they do dissolve and do stay separated is how the charges stick to the water. I show my solid, and specifically, I show it together. And even more specifically, I show it down here at the bottom because eventually that's going to fall down there to the bottom. We do the same thing on each one. If it's aqueous, we break it into cations and anions. So our left two beakers will always be broken apart. They'll always have charges, and they'll always be based upon the coefficients and the subscripts. The right side will have one thing that's broken apart, sodium and nitrate with the solid. So over here we have two sodium nitrates and one PbSO4 solid. And down here we have 1, 2, 3, 4, 5, 6 sodium chlorides, positives and negatives, with one iron 3 carbonate. So make sure you check out the videos as well. The other worksheet wrapped up the notes. All of these are practiced on this double replacement reaction assignment here on mastering. If you haven't done that yet, make sure you do that. And then our GPI is going to practice the balancing, the word equations, and the writing and drawing that we've been practicing all week.